Welcome back to the final episode of Engine on this, the day of my birth. So, for this last video, what we're going to go over is game object lifecycle, the factories, the sprites, the visualizer, and the math tools, the colors, and of course the documentation. So to start off with, what we have is the game object, and in the game object we have, of course I'm going to lose the game object, there it is. We have scene entry, scene exit, and inside of the bullets, you can see here that they have scene entry and scene exit, and what they do here is, they handle all of their registration, their deregistration, all the housekeeping, so that they don't have to constantly be reconstructed before they send themselves back to be recycled by the factory. And inside the factory, I have a list of the active bullets, and then I also have the graveyard bullets that are there. So when the factories are cleaned up, it goes ahead and it deletes all of the graveyard bullets, and of course all of the active bullets. So if there aren't any hanging pointers or any memory leaks in there. So yeah, basically that's everything for the factory. I have a couple factories going on. I have the enemy bullet factory. I have the player bullet factory, same thing. You can see here that it has the active bullets and the graveyard bullets. I also have I have factories for the enemy tank. So you can see here, same thing. Also, it deletes everything that needs to be deleted, it puts the active enemy tanks when they're created and removes them when they're recycled. And then basically that's pretty much it for the factory. So not much going on there. It's pretty much the same thing that we did last quarter. So next up is the sprites. So for the sprites, I have let's see, where do we have this sprite? There we go. So for the sprites, I have the obvious constructor that assumes that the entire image is a sprite. The flyweight constructor, where you can pass in the start x, start y, and the size of the box. The set position, get x, get y, set the angle, get the angle, register the draw, deregister the draw, set the scale, get the X scale, get the Y scale, and deletion of the sprite, of course. And here you can see that there are the command patterns for registering the actual sprite. Yeah, so if we go into the sprite.cpp, you can see that all the way up top here, you create the sprite. It handles all the housekeeping. It applies the correct shader. Over spring break, I'm going to change this to be a different sprite shader, or it's going to store this shader in the sprite manager, so that way it doesn't have to constantly go into shader manager and get the sprite. So I'll handle that over spring break, because I know we talked about that. Here we have set position, a bunch of all the math. So all the math is kind of hidden, tucked away nicely. There's the register draw, deregister draw. It creates registers the command pattern to the scene to be executed. Set scale, get the X scale, get the Y scale. Deletion of the sprite deletes all of the stuff, so there's no hanging pointers. And then obviously get current scene, register, all that stuff. This is called when the command pattern executes, and then here's the creation of the command pattern when the sprite is created. That's pretty much what we got going on for the sprite. So for the actual sprite manager, which is there's constant deletion. So if we go to the scene, you can see that where is the scene? Where did the scene go? Oh, that's silly. What on earth? I can't believe I just lost the scene. I thought the scene was here. Unbelievable. There we go. Okay, so here you can see that the sprite manager here processes these elements. Same thing for the instant deletion. It stores the iterator in the position that it's at, so you'll never get lost. Unlike the scene, I'm really confused about where the scene went. That is very curious to me. I always thought it was under the scene manager, but I guess not. I'll find it. It'll definitely be somewhere. So yeah, basically that's how that works. You can see that the draw order is exactly it's the sprite comes after everything else. I don't have any layers or anything for right now, so we're just gonna leave it like that. Other than that, let's move on to the visualizer. So for the visualizer, God, I'm losing everything here, aren't I? The visualizer here is a singleton, of course. So it only ever has one graphic object. So basically, it oh my gosh, I'm clumsy right now. It So basically what happens here is that it creates the graphic object when the visualizer is created. I don't know if you remember the initialize in the beginning of the game loop. And then what happens is that a show B sphere is called, and then it adds the command to the scene manager, and it stores the world and it stores the color. Or that this is the actual command, and then oh, the draw. Okay, so each collision volume B sphere has its own command, and then it adds the draw command, stores the world, stores the color, and then when it comes time to render that B sphere, it goes ahead, it sets the world, sets the color, and renders the object. So it does it through two separate things. And I can show that that's how that works, because here are the draw commands for the visualizer draw commands. So you can see the draw is overloaded. It's just a command here. It's a base command. And then there's the visualizer draw manager, which basically just draws the visualizer and then pops the back. I think I showed this in the collision one. So you can see that there is only ever one sphere in the visualizer, and that sphere is right here. So when we go back here, you can see that it just sets this object to be this, and then renders it. So since this is a singleton, that's what it's going to do. It's not going to create a new one. So to finish off, I have my math tools. So basically you can see here it's not a singleton, it's a static, and it has just this function, which is just the math for collision sphere detection. Returns true if it works, returns false otherwise. Also, I have the colors, which is in here. And you can see I have black, white, gray, and red. And if I click on this, you can see that in here it has the RGB values for those colors. In here I have documentation for my colors. You can see it shows the colors that are available. I also have the Engine Math Tools documentation that says what's going on for that. I have a bunch of other documentation for the resource managers. The game objects have the things that they need. I have a little getting started section here. Resources must be loaded on the load all resources file. That's what I did first. Create a new scene class inherited from scene. That's what I did second. So if you look over here, you can see that in my scene here, there's a demo scene, and it basically has all of these. Everything is loaded in the initialize, and then everything is cleaned up when the demo scene is deleted. Create all desired objects and station them custom scene initialize. Steps on how to create a game object can be found in the modules section of the site. Call the scene manager, change scene with the new custom scene. You can see that here I did that in load all resources down at the bottom here. I did scene manager, change scene, new demo scene, and then in here you now have a custom scene, and it should work, because if you register all those objects according to how the game object works for the inputables and all of the the updatable, you can see that it registers the updatable if you call register updatable. And then there's more details here if you really want to know more about each of the classes and the different things that can be done here. The sprite and the different there's some example code there for how to create a sprite. I want to expand upon this over spring break, but it's just something that takes so much time, so much details to do. So I'm going to go ahead and wrap up this video, and then in the next video I'm just going to finish off by showing my demo really quick, and that'll be it. Thanks for watching.